Good morning everybody. Today in our class we will discuss about the conversion from binary number to octal or hexadecimal number and vice versa. Previously we have done conversion from decimal to binary, decimal to octal and decimal to octal and decimal to hexadecimal, and then from binary to decimal, octal to decimal and hexadecimal to decimal number system. And now we will learn how to convert from binary number system to octal and hexadecimal number. Okay, the procedure is very easy. A binary number is converted to octal or hexadecimal number by making groups of 3 and 4 bits respectively and replacing each group by its equivalent octal or hexadecimal digit. Now the fact is, here we have already learned a chart for octal and hexadecimal chart. Please just we have to first see that chart. This one, look at this chart. Decimal and binary is equivalent of hexadecimal number. Hexadecimal symbol are here. 0 to F, 0 equivalent value grouping of 4, 0 0 0 0, 4 zeros are for 0, for 1 0 0 0 1, for 2 0 0 1 0, like this. This is the complete chart for hexadecimal number and its equivalent binary number form. And the same chart is here. This is from octal number system. Decimal values are here and their equivalent octal number is here. Binary octal digits are here and binary numbers are here. All those things, right? You have to just go through these two charts, octal and hexadecimal. And now we will go there. Conversion. Just wait. Okay, where is it? Okay, conversion from binary number to octal and hexadecimal number by grouping of 3 and 4 bits respectively. First of all, we will convert binary number to respective octal number. Okay, now see, what is the meaning of grouping of 3 bits? Grouping of 3 bits means nothing. This is just only when you were given some number. Suppose here the example, convert 10101100, and this is in a binary form because the base value is here is 2 given. This is given. We have to convert this to its equivalent octal number. Now what is grouping means? Make group of 3 bits of the given binary number right to left. This is very important point. From where? From right to left. We have to make the group from right to left. Here first of all we will group this one, right? 0 1 1, this is our first group. After that 1 0 1, this is the second one, and then 0 1 0, the number is completed here, right? 0 0 1, then 1 0 1, 1 0 1, and then 0 1. See, here are only 2 bits, but we have to make 3 bits, group of 3 bits. So we just add 1 0 before this one, 0 1 0. Adding zeros to the left side will not hamper the proper value of the given number, so we can add zeros in the left hand side of the given number. Okay, and this way we can make the groupings. After the grouping is completed, then what we will do? We will write down the respective octal number. Okay, we just go through that particular chart where the octal numbers of respective values are given there, and here we write down like this. Write octal number for each 3-bit group. 0 1 0 represent what? Represent 2 in octal. 1 0 1, this is representing 5 in octal number system, and 1 0 0, this is representing 4 in octal system. So the given number is converted to its equivalent octal number, and here we get the resultant value 254 to the base 8. Okay, I think it is clear to you how to convert a given binary number to its respective octal number with the help of grouping of 3 bits. In the same procedure, we can convert it to its binary number to hexadecimal number. First we discuss it, then we will discuss this one. So look here. Oh, there is another example, binary number to octal number. This is completed, and then octal number to binary number. The procedure is same. How to? Just the vice versa procedure, right? Each octal digit is an encoding for a 3-digit binary number. Look, convert 705 to the base 8 to binary number. First we write down this octal digits 705. Then write 3 bits binary value. Write down the 3 bits binary value for each digit. For 7 we can write here 111. For 0 this will be 000. For 5 this will be 101, and the resultant value will be 111,000,101. Base value will be 2. So this is the way we can convert binary number to its octal number, and from octal number to binary number. Then comes another procedure, binary number to hexadecimal number. This is very important part in conversion, because here we will make the group of 4 bits. In octal number system we have to make the group of 3 bits, whereas in hexadecimal number system we have to make the group of 4 bits. Same procedure, just grouping, and grouping will always take place from right hand side. Okay, from this side to that one. And here we will take an example, 011 010 1100 to the base 2 means this is a binary number, and we have to convert it to its equivalent hexadecimal number. So make group of 4 bits of the given binary number right to left. This is very important. I repeat, right to left. We cannot make the group from left to right, because if there is any shortage of bits we have to add zeros in the right side, then the value of the original given data will be changed. But if we add zeros in the left hand side, that will not change the value of the given number. That's why when we make the group, we always make the group from right to left. So now check how the grouping is considered here. 0011, this one, first group. Here is my first group, 0011. Then 0101, second group is here, we can see here, and then 10. See, last time we get 10, only 2 digits are left in the given number. That's why we have to put here 2 zeros, extra zeros in the left hand side, just to make it a group of 4 bits. And now we have to write down the symbols for the respective values. And for each group we can write here, for 0001 it will be 1, for 1010 it will be capital A in hexadecimal number, and for 1100 it will be capital C in hexadecimal number. Therefore we get the answer here. Okay, 1 AC to the base 16. I repeat that this base value is very important when we are converting any number from a given number system to another number system. We have to mention the base value there. When we converting anything, we have to mention the base value here, otherwise it will be meaningless. For number system, when we are studying number system, it will be meaningless. We cannot understand from which number system this is belonging, right? So always write down the base value when we are doing any conversion. and in the same procedure we can change the hexadecimal number to binary number system, the same conversion like octal to binary. Here we are doing the same thing. Suppose here is given that convert 2 3D to the base 16 to binary number. Now hexadecimal digits are 2, 3 and D. Just write down the grouping of 4 binary bit, respective binary bit. 2 means this one, 3 means this one, D means this one, 1101. Then write down the total number is here, grouping of 4 bits, and with the help of grouping of 4 bits we can convert hexadecimal number to binary number and binary number to hexadecimal number. This is the easiest way to conversion from binary to hexadecimal and hexadecimal to binary, and grouping of 3 help us to convert octal to binary and binary to octal number system. Okay, thank you. We will discuss in the next chapter conversion of a number with fractional part. Okay, after this you will go through all the classes. This is very important because conversion is a very important part in number system, and this is very common question in every exam. More or less there are questions on conversion, so please do practice very well, and if there is any doubt please ask me and I will definitely clear your doubts. Okay, thank you, and please subscribe my channel, like and share it. I think it will be helpful for more and more students. Thank you.